Good morning, Steve Brown. I'm going to give you a real quick update on the peanut genome initiative that we've been working on for starting our 5th year now. It's real impressive what these breeders have done, some of the varieties they've been talking about. The goal of the Peanut Genome Initiative is to help these breeders, to give them tools to develop even better varieties with better traits to help you, the growers, and the entire industry. So we're talking about improving peanut traits without the controversial GMO technology. Corley mentioned that. This is not GMO technology. You hear that word genome and you think this is GMO, but it's not. This is just a quote from Dr. Scott Jackson at UGA up in Athens, and he's talking about how this is a great detective story, how there's clues and we're discovering the genetic code for the peanut plant. And it is a mystery, and it is fascinating. There are many hidden secrets to that peanut plant that we don't know yet. And we are making incredible advances right now in uncoding some of this stuff and figuring out what these genes are, what they do, and how they can help us. Other crops have already completed their genome maps. We're behind cotton and corn and soybeans that have already been done. But I think you'll see that if you study this, and by the way, our annual report is on our website. If you want to look at some of this, you can go to the Peanut Foundation, Google Peanut Foundation, and you'll find our website, and our annual reports are there for you to look at. But I think you'll find that the genome work that's being done and almost complete for peanut is going to be even superior to what was done in some of these other crops. And there's a couple of reasons for that. One, the technology has increased since the genomes were done for these other crops. The technology has gotten better and better. And I think a second, even more important reason is that the close-knit peanut community is so good. Our scientists are so good, and they're so collaborative. They work with each other instead of competing with each other. They have worked together and have done a fabulous job of doing this in record time and with record quality. Peanut genome is extremely complicated, more complicated than a lot of other plants. It's very large, and it's what they call tetraploid. It really has 2 genomes within that peanut plant. So it is complicated. Both of the subgenomes, the A and the B, which came from originally from wild type peanuts that came together 10,000 years ago to form cultivated peanut, those genomes have been worked out and they've been published. It was a feature article in Nature Genetics, a very prestigious journal. So we've got really high quality data on those. The actual cultivated peanut, the sequence is done. We've got to put it all together now. It's like pieces of a puzzle that you have to put together. We're 95% complete with that. So just real soon, in the next few months, we hope that we will have a completed assembly of the cultivated peanut genome, and that's very exciting. That's a map. It's a map of the genetic material for peanut. And as we study this map and everybody starts working off the same map, we're going to find genes and we're going to find markers for those genes and going to start putting that map to work to make better peanut varieties. We have a great online resource called Peanut Base. Once you get all this data, it's huge. There's 3 billion base pairs in the peanut genome. So the file that contains all this data is enormous. So that has to be put somewhere. It's in Peanut Base. We've got a great story to tell there that with our genetic data, it's very organized, very useful. Breeders can go to that site and find out what they need to know about the genetic material. The goal, like I said, is marker-assisted selection. Corley mentioned this. It's already being used. We already have markers, and they are being used. Some of the varieties that have been released because of marker-assisted selection. This is just the tip of the iceberg. There's going to be a lot more markers coming. There's going to be a lot more varieties that are going to use this technology, and we're going to start reaping some of the benefits of this work very soon. The diversity within cultivated peanut is fairly narrow. We would hope to have a large diversity, very wide selection of genes, and we can go in and pick what we need. That the diversity of cultivated peanut is not that great, but there are wild species peanuts that contain a lot of genes and a lot of traits that we would love to have in cultivated peanut. The scientists in this program have actually developed ways to get genes out of wild type peanuts and incorporate them into cultivated peanut. So this is a huge increase in the amount of diversity that we have to access. And we all know that if you've ever seen a wild type peanut, it's not very desirable, not something you'd want to grow. But those wild types may have some incredible resistance to disease that we could really use in cultivated peanut. And if we could pick that gene out of that wild type and put it in a cultivated peanut that has good agronomic characteristics, then we've really made some advancements. And that's what one of the things that's happening with the Peanut Genome Initiative too. A lot of interest in the wild types and the diversity there, and being able to mine those genes and use them in the future. With these new genetic maps, we can begin to find genes and groups of genes that convey known traits. Our scientists have already developed a pipeline of these inbred lines, thousands of them, that actually serve to kind of segregate out a lot of these genes, so where we can start picking out and finding this particular set of genetics goes with this particular trait. And then we can start unraveling some of these mysteries and figuring out where these traits are coming from, what genes are coding what to make that trait actually express. We've just begun to find those genes and match them to the traits, and again, we're at the tip of the iceberg there. Peanut industry has funded the Genome Initiative for 5 years. 2017 is the last year of that funding. Most of the original goals of the project have already been met, and we're learning more every day, so we're really on a bonus now for what we signed up for. Marker-assisted selection has already been used to develop newly released varieties, and we got a lot more on the way. So I'm real excited about this. I think the peanut industry has gotten its money's worth out of this investment in research, and we look forward to a really strong research effort in the future to start building on the foundation that's already been laid, and start cranking out some varieties with some incredible traits that you and your fathers and grandfathers never dreamed about having. Thank you for your time.